In today's lesson, we are going to start talking about sequences. The word sequence is being used every day. But one thing you have to remember in the sequence, the order of items is very important. For example, if you're programming, as you know, the design is from top to bottom. If the order is not preserved, then the program is not going to work. If you are building a house, you know that you have to follow a series of steps. If the steps is not in order, then what you are going to get is not a proper and safe building. Now in mathematics, we define a sequence, a set of numbers. Usually they are separated with commas, that they have a particular order. For instance, I can have a sequence in mathematics, something like 1, 2, 3, 4, and so forth, or -10, -5, 0, and so forth. Now we define a sequence as an ordered list of numbers identified by a pattern or a rule that may stop at some number or continue indefinitely. If you look at this sequence, it starts at 3 and it stops at 15. There are 4 terms here. Every one of these numbers are called a term. Now the rule here is that you have to add 4 to every previous number to get the next number. The next sequence, as you can see, is an infinite number of terms here. The way that we know that there are infinite number of terms is the 3 dots at the end. Now the rule here is going to be, if you multiply 2 by 3, you get 6. If you multiply 6 by 3, you get 18. If you multiply 18 by 3, you get 54. Now if you look at these two sequences here and here, again every element in the sequence is called a term. And if you can somehow find a formula to write every term based on the term number, then that formula we call explicit formula. Again, for example, write the first 3 terms of each sequence. Now t sub n represents the nth term, and n is a term number. So the first one says the nth term is equal to 3n squared minus 1. I have to write the first 3 terms in this sequence. This means that t sub 1 is equal to 3 times, remember t sub 1 means n is equal to 1, so 1 squared minus 1. 1 squared is 1, so 3 times 1 is 3 minus 1 is 2. T sub 2 is 3 times 2 squared minus 1, which is going to be 3 times 2 squared is 4, so 3 times 4 is 12 minus 1 is 11. T sub 3 is 3 times 3 squared minus 1. 3 squared is 9 times 3 is 27, minus 1 is 26. So we can write the sequence like this one. T sub 1 is 2, T sub 2 is 11, and T sub 3 is 26. So this is our sequence. And we can put the 3 dots here. And based on this explicit formula, I can write this sequence and produce as many terms as I want. The next one is t sub n is equal to n minus 1 over 1. So I can write that t sub 1 is 1 minus 1 is 0. 0 divided by 1 is going to give me 0 again. T sub 2 is going to be 2 minus 1 over 2. 2 minus 1 is 1, so 1 over 2. T sub 3 is 3 minus 1 over 3, which is 2 over 3. So my sequence becomes 0, 1 over 2, 2 over 3, dot, dot, dot. The next example, we have a sequence like this one. You're supposed to make a table of values using the term number and the term and calculate the finite differences, the first differences, and if I need the second differences, then graph the sequence using the ordered pair term and term number and term, and then determine an explicit formula for the nth term using the function notation. So for this first sequence, part A, I'm going to have n, which is my term number, and then you have t sub n. So term 1 is 7, term 2 is 12, term 3 is 17, and term 4 is 22. Now the first differences, I call it D1, is going to be 12 minus 7 is going to be 5. Then it's going to be 17 minus 12 is 5. Then 22 minus 17 is going to be 5. Since the first differences are the same, then it means that this is a linear relationship. Now I'm going to go and plot the ordered pairs. So this is going to be my n, and this is going to be my term number. I have terms from 7 to 22, so if we assume this is 25, then if you divide it by 5, we're going to get 1, 2, 3, 4, 5. So this is 5, 10, 15, 20, and 25. It says term 1 is 7, so term 1 is going to be 1, 2, 3, 4, 5. So term 1 is going to be around here. Term 2 is 12, so term 2 is going to be somewhere around here. Term 3 is going to be 17, so it's going to be somewhere around here. And term 4 is going to be 22, so it's going to be somewhere around here. Obviously, you can see that this is a linear type of relationship, and a line can go through the points. Now, the next part of the problem says find the explicit formula. To find the explicit formula, we go back to table of values. Remember that the first differences, if they are equal, it's going to be a linear relationship, and the first differences is the slope of the line. So from here, I can write a t sub n, the nth term, is equal to, remember, it's going to be linear, so it's going to be mx. X here is really n, so mn plus b, which is the y-intercept. Now the slope is m here is 5 times n plus the y-intercept b. To find the y-intercept, I'm going to pick one point, sub it back in the equation, and then find b. So let's say we pick this point when n is 3, t sub n is 17. So t sub n is 17 when n is 3. Now 5 times 3 is 15, so I take it to the left. So I get b is 17 minus 15, which is going to be 2. So t sub n is going to be 5n plus 2. This is my explicit formula. To test the formula, let's pick the fourth term, which is 22. If I put 4 here in this equation, I get t sub 4 is equal to 5 times 4 plus 2, which is going to give me 22, which is exactly what it should be. The next example is the sequence 1, 10, 25, and 46. Again, we have to write the table of values. So n is my term number, t sub n is the value of the term. So term number 1 is 1, term number 2 is 10, term number 3 is 25, and term number 4 is 46. Now let's find the first differences. Now 10 minus 1 is 9, 25 minus 10 is 15, and 46 minus 25 is 21. It is obvious that the first differences are not the same, so this is not linear. I'm going to continue with the second differences. 15 minus 9 is 6, and 21 minus 15 is going to give me 6. Apparently the second differences are the same, so this tells us that this has to be a quadratic equation. Now, we are going to plot the graph. So we are going to say this is my term number n, and the Tn is the term value. We are going to say this is 10, this is 20, this is 30, and this is 40, and this is 50. Now term number 1 is going to be 1, which is going to be somewhere around here. Term number 2 is going to be 10, so it's going to be here. Term number 3 is going to be 25, so it's going to be somewhere here. And term number 4 is going to be 46, which is going to be somewhere around here. And as you can see, the graph looks like a parabola which opens upward. Now the question is how you can specify the parabola. There are so many ways you can do it. One way is to write the parabola in general form and then evaluate the parabola at different n values and then specify a, b, c, which are the coefficients. So let's go ahead and see if we can find these coefficients. Let's write the equation of parabola in general as y is equal to ax squared plus bx plus c, where a, b, c are real numbers. We are going to first use n equal to 1. If n is 1, then t sub n is 1. Remember, n here is x and t sub n is y. So when n is 1 or x is 1, then y is 1. So 1 is equal to a plus b plus c. I just substituted x equal to 1 here and I got a plus b plus c. So that's my first equation. The second one says if n is 2, t sub n is 10. So I can write 10 is equal to, if n is 2, then 2 squared is 4. So you get 4a plus bx becomes 2b plus c. This is my second equation. The third equation, I'm going to use n equal to 3. Then t sub n is 25, so I get 25 is equal to, if n is 3, then 3 squared is 9, so 9a plus bx is going to be b times 3, which is 3b plus c. So now I have these three equations in three unknowns, and as you know, since we have enough equations for number of unknowns, we can solve it. Let's call this one equation 1, this one equation 2, this one equation 3. The first thing I'm going to do, I'm going to find equation 2 minus equation 1, meaning this equation minus this equation. This means 10 minus 1 is 9. 4a minus a is going to give me 3a. 2b minus b gives me 1b. And c minus c gives me 0. So the first subtraction, I'm going to get one variable to disappear. The next one I'm going to do is I'm going to subtract equation number 1 from equation number 3. So now I'm going to consider this equation and this equation. So I'm going to say equation number 3 minus equation number 1 gives me 25 minus 1 is going to give me 24. 9a minus a gives me 8a. And 3b minus b gives me 2b. And c minus c gives me 0. So now I have two equations in two unknowns, which is easy to solve now. To do that one, I'm going to multiply this equation by 2, so coefficient of variable b is the same as the next equation, and then I subtract each other. If I multiply this equation by 2, I'm going to get 2 times 9 is 18, 2 times 3b gives me 6a, 2 times b gives me 2b. And the next equation is 24 is equal to 8a plus 2b, which is the same equation as this one. Now I have these two equations. If I subtract them from each other, b is going to be gone. So 24 minus 18 is going to give me 6. 8a minus 6a gives me 2a. And 2b minus 2b gives me 0. From here, I divide by 2. So I get a is equal to 3. So I found the first variable, a. Now I have to find the second variable, b. I'm going to use, let's say, this equation now. I'm going to say 24 is 8 times a, which is 8 times 3, which is 24, plus 2b. From here, 24 cancels 24, so I get b is equal to 0. Now, a is equal to 3, b is equal to 0, then I can find c. To find c, I go back here and pick any equation I want, and I substitute a and b. Let's pick the first equation, seems to be the easiest one. So I'm going to say 1 is a, which is 3, plus b, which is 0, plus c. I move 3 to the left, and from here I get c is 1 minus 3, which is minus 2. Now I have a, b, c, so I can write that c sub n, which is the same as y, is equal to ax squared. A is 3, and x is really n, so n squared, plus b. b is 0, so forget it, plus c, which is negative 2. So this is going to be my explicit formula. Now to test that, as usual, as I said before, always try to test your answer to see if it's correct. So I'm going to go ahead and pick one term, let's say term number 3, which is supposed to be 25. So I'm going to say t sub 3 is equal to 3 times 3 squared minus 2. 3 squared is 9 times 3 is 27 minus 2, which is 25, which is exactly what we should get. Now we are going to define a new term which is called continuous function. We define a continuous function is a function which every real number in x is mapped to another real number in y. This means that there is no hole in your graph when you plot your x versus the y. For instance, in this graph that you see here, the graph goes from left to right, and for every x value that you pick here on the x-axis, there is a corresponding y value. This type of function is called continuous functions. Opposite to the continuous functions are what we call discrete functions. In a discrete function, as you can see from the graph to the right here, there is discontinuity in the function. The function jumps from one interval to another one. Or, as you can see from the graph, there are holes in your graph. This type of functions, when you graph it, you get what we call stepwise functions. Like a stairway that you have steps, these functions, they have something which is very similar to steps, like the graph again that you see in front of you. In these graphs, there are separate points that are not connected. To give you examples of difference between continuous function and discrete functions, let's say the relationship between your age and your height. As you know, when your age is increasing, your height also increases. Now, your height can be any value, which can be either integer or it can be a decimal value. For instance, it can be 2.5, let's say 5.5 feet. Now, at the same time, look at the relationship between your age and the number of children you're going to have. The number of children cannot be any decimal value. You cannot have 2.5 kids. You have either 2 kids or 3 kids. So the relationship is represented by a discrete function, not a continuous function. In the next example, you have the case of a battery which the charge in the battery decreases by about 2% every day. The relationship between the charge in the battery and the day is represented by this equation. The first question is that how much charge is left after 10 days. So this means that D is equal to 10, so we have to find C of 10. C of 10 is 100 times 0.98 exponent 10. If you use your calculator and change and evaluate this one, this is going to be about 81.71%. So this is the amount of charge which is left in the battery. Now, the most important part is the question, is this a continuous function or a discrete function? This is a continuous function. The reason is that the charge in the battery can be any value, any decimal value. You can have, as in this case, is 81.71%. You can see that you have a decimal value 0.71. There is nothing wrong with having, this value. So that's why it's called a continuous function. The next question says that you have a certain bacterial which starts with 200 and doubles every year. The equation which relates the number of bacterial and the time in hour is given by this formula. The first part of the question says how many bacteria will be there after 10 hours. So we have to find n of 10, which is going to be 200 times 2 exponent 10, which is going to give us a 204,800 bacteria. Now, it's asking, is this function continuous or discrete? The function is discrete. The reason is that the number of bacteria which is left after t hours cannot be a decimal number. You cannot have 200.5 bacteria. Either you have 200 or 201 bacteria. So this is an example of what we call a discrete function. The next question says the value of a new car purchased for $78,000 depreciates at the rate of 15% in the first year and 4% every year after that. Part A says determine the value of the car at the end of the first year, the second year, and the third year. Write these values as a sequence. The first year, let's call it T sub 1, is going to be 15% is going to go down. So what the value of the car which is left is 100% minus 15%, which is 85%. 85% is 0.85. So T1 is 78,000 times 0.85, which is going to give us $66,300 is the value of the car. In the second year, the value of the car decreases by 4%. So this means now is 100% minus 4% is 96%. So it's going to be 66,300 times 0.96, which is going to be 63,648. The third year is going to be again this times 96% because it goes down by 4%. So it's going to be 63,648 times 0.96, which is going to be 61,102.08. This means that the sequence is going to be 66,300, 63,648, 61,102.08. This is going to be the sequence. Now it says determine an explicit formula for the value of the car at the end of the nth year. Now if you look at this sequence that we have, this is at the end of the first year, second year, and third year, then you can see that every year 4% is depreciated and the initial value is 66,300. So I can write V, the value after n here, is going to be the initial value times 0.96 exponent n minus 1. Now n is the number of years, so n has to be an integer, a positive integer, and n has to be greater than 1. For instance, if n is 1 at the end of the first year, 1 minus 1 gives you 0.96. Exponent 0 is going to give you 1, so the value of the car after 1 year, at the end of year 1, is going to be 66,300, which is correct. If n is 2, then it's going to be 2 minus 1, which is 1, so 0.96 times 66,300. We did it before, and it's going to give you this one, and so forth. So this one is the explicit formula. Now the next part of the question says, what is the value of the car at the end of year 20? So V20 is going to be 66,300 times 0.96 exponent 20 minus 1. If you use your calculator, this is going to give you 30525.79. Now the question says, is this realistic? Depending on how you keep the car, if it's involved in an accident, if you take it to garage and do all the maintenance every year, then probably the price seems to be okay. But if you don't do those things, then this value after 20 years is a little bit over exaggerated. The value is too much.